Hi everyone, welcome to this week's session. Today we'll be touching on chemical bonding, specifically the factors that affects the strength of a simple covalent compound. So let's take a look. Over here we are looking for a pair where the boiling point of the second compound B is higher than the first compound A. So for boiling point, what does it depend on? It depends on the strength of the attraction, correct? So we have to firstly take note, what is the structure? So let's look at number one. Well, in number one, for A, this is a benzene ring with NO2 and OH. Therefore, it is a simple covalent compound. If you look at B, also a benzene ring with NO2 and OH, but on different sides. So therefore, both are simple covalent compounds. And there's three different types of interactions. First one would be ID-ID, which is present in all types of simple covalent compounds, but is the main one for nonpolar molecules. Next, PD-PD. PD-PD interactions is present in polar molecules. Okay, so like I said just now, for polar molecules, they contain PD-PD as well as ID-ID. ID-ID is present always in your simple covalent compound. Okay, last one will be more special. It is hydrogen bond. So hydrogen bond, I have two criteria. A, it must have a lone pair on a N or O or F atom, and B, there must be hydrogen bonded to N or O or F. Therefore, this hydrogen bond is between the lone pair on NOF to the hydrogen bonded to NOF. So let's take a look. For A, there's NO2. So just nice, I have my lone pair. Over here, if I were to draw it out, N has 5 valence electrons, and when it forms this NO2, it uses up all 5. So therefore, there's no lone pair of electrons on N. However, there are lone pairs on oxygen. So the lone pair on oxygen will form an intramolecular hydrogen bond with the hydrogen, since they are in close proximity to each other. So since it forms intramolecular hydrogen bond, it means that there will be less available lone pair and hydrogen for intermolecular hydrogen bond. So if there's less extensive intermolecular hydrogen bond, then there will be less energy required to overcome the hydrogen bonding. And therefore, there will be lower boiling point. And then for B, it's the same thing, except that NO2 and OH are further apart. So therefore, there is no intramolecular hydrogen bond. Okay, no intramolecular hydrogen bond. So therefore, there can be more intermolecular hydrogen bond. Therefore, more energy will be required to overcome the more extensive hydrogen bonding. Therefore, it will be a higher boiling point. So therefore, this agrees. The boiling point of B is higher than A. So hence, this is part of the answer. And then number 2, let's take a look. So number 2, this is a skeletal structure. So let me count the number of carbons. 1, 2, 3, 4. 1, 2, 3, 4. So therefore, this means that these two are structural isomers. They have the same molecular formula, just that A is more branched. Okay, more branched. So if it's more branched, it has a more spherical shape. See, if I were to draw it out, it's more spherical. So since there's a more spherical shape, there's lesser surface area of contact with another molecule. So therefore, there's a lower surface area of contact between molecules. So therefore, If there's less area of contact, there's lesser ID-ID interactions that can be formed between molecules. Therefore, since there's lower ID-ID interactions between molecules, there will be lesser energy required to overcome it. And therefore, there's a lower boiling point. And then for this one, for B, since it has a more linear shape, therefore, there's a larger surface or area of contact between molecules. Therefore, there's an increase in ID-ID interactions between molecules. And so, more energy required to overcome this greater and more extensive ID-ID interactions between molecules. Therefore, it has a higher boiling point. Therefore, B has a higher boiling point than A. So, we take that as the answer. Then lastly, number 3. So for number 3, let's take a look at the structure. This is a alcohol. So between alcohol molecules, it can form hydrogen bonds. Right? So therefore, it can form intermolecular hydrogen bonds. And the next one is an ether. Okay, so if you take a note, there's 1, 2, 3, 4, 1, 2, 3, 4. Same number of carbon atoms, therefore they are isomers of each other. However, being an ether, it does not have a H bonded to the O. So therefore, it does not have any hydrogen bonding. Therefore, it has PD-PD instead. So between hydrogen bond and PD-PD, definitely hydrogen bond is stronger. So therefore, over here, more energy required to overcome stronger hydrogen bonds between A molecules. Then weaker PD-PD interactions between B molecules. So therefore, B has a lower boiling point, which is not what we want. So if we want 1 and 2, the answer is B. Hope that y'all have much better understanding of this. Thank you so much for subscribing and see you next week.